presented by Oron Gutman. Right? So this talk presents research on how shaded and repackaged libraries propagate in the wild. So based on analysis of real Maven repositories and build artifacts. Let's give him a round of applause.
By the way, it's also his first time talking at BSidesNYC, so now we're on
Thank you very much for having me. So, my name is Oron. I'm the co-founder of CTO of Hopper Security. We are in the area of static function level reachability analysis for both SCA and container scanning. Before Hopper, I spent 15 years in vulnerability research, managing both vulnerability researcher and software engineer. Yes? What? I'm sorry. Now? Is it okay? Okay, great. This one? Great, thank you. So, how do we manage OSS risk today? So, the first thing that we want to do is to get the visibility to what we have in our software. We can do it with something called SBOM, but essentially it's getting a list of all of the software components that we have in our code, in our binary, depend on what we're scanning. And this is the first thing that we want to do. The second thing is to identify what risk do we have in each component. So we can cross-reference each of the component, the dependencies with NVD, OSV, or other vulnerability database. Or we can do it with a proprietary one. But essentially, this is what we need to do in order to identify the risk. It's the same thing for license scanning. We will start with the inventory and then we will cross-reference it with a license database. The third thing that we want to do is to prioritize the risk. Now most of the tools, most of the teams, what they are doing is based on the CVSS score or the EPSS for the most advanced or the CISA-CAV, or looking for known exploits. And then the fourth part is the remediation. Basically, it's most of the time it's a version bump. We need to change the version from version A to version B for the non-vulnerable part. When it's very difficult, we can consider doing backporting. So, why are we talking about Java today? So, Java is the most, it's the number one backend language in the Fortune 500 companies. Nearly 50% of the Java applications in those companies of the application is built by Java. It's very complex ecosystem. There are a lot of frameworks like Spring and Jakarta that bring a lot of dependency. It's very transitive. A lot of dependency bring another dependency that bring in turn more dependencies. And this requires some creative methodology to solve things there that we will talk about this later. And then the impact of vulnerability in Java is very big because one vulnerability can affect hundreds of thousands of other libraries. For example, the log4j incidents. So how do we build Java application? We have today 3 major build system. We have the largest one, which is the Maven. We have also Gradle. It's a script-based Build system, it's like a makefile in C and C++. And we have Bazel by Google, which more oriented to the build performance and reproducible build. So, how do we build application with Maven? We have a simple thing that we call POM. It's an XML. It's defined metadata, which for example, the group ID, the artifact ID, and the version, which essentially the identification of the binary that we are going to build. We specify the dependencies with the version, the direct dependencies, and all the build lifecycle. We take the source, we take the dependency. We need to resolve the dependency because now we get the direct dependency. We get them from most of the time from Maven Central. We can get them from internal artifacts, JFrog Artifactory or Sonatype Nexus, for example. Then we will need to resolve conflicts. Maven is doing this by what is nearest to the root. Direct dependency is get more priority on transitive dependencies. And then we compile everything. We declare in the lifecycle the test that we want to run. And then we package it into, there are four main packages type that we have. We have jar, war, zip, and ear. And the most common is basically the jar. So what is jar? Jar is basically Java archive. There is inside the class file that we compiled from the source. We have some metadata. Because it's a zip, it could contain a resource file, configuration file. Log4j have a lot of configuration files in it. And it can be an executable. Executable means that there is a main class, a signature of main class. That's the only thing that we can run the Java application, or it could be a library without a main application. It will be a dependency in other projects. So, what is the challenges in executable jar? Basically, the dependencies. Because to run a Java application, we need to specify all the dependency in the class path. Here you can see the Java minus CP. I can specify jars. I can specify a directory which contain other jars, and specify the main entry point. By different environment, this could lead to class path error, class path difference that could lead to runtime error. So one way to solve it today is to put all together in a container. But before there were containers, there was something called UberJar that basically pack all the classes that from the first party code alongside with all the dependencies together. And now we have a single jar that contains everything, and we can run this jar alone. So there is two main build tool to automate it. There is a plugin in Maven called Maven Shade plugin, and in Gradle it's Shadow Jar plugin. Now let's talk about what is the challenges in the library. We talked about the executable, but now we have also libraries that have their own challenges. So basically what we are talking about is the dependency conflict, because libraries, when we publish them to, for example, Maven Central or internal Artifactory. They are coming with other POM that specify what are the dependency that require to this library. So when we resolve the dependency, we take in account the library from this POM, and we resolve it, and we resolve all the tree until we do not have dependencies anymore. So what's happened when two libraries require the same dependency but in a different version? Maven will resolve it. It will choose the nearest to the root, but if someone wants version 1.0.0 and the other one wants 3.0.0, three major differences, so one of them is going to win and one of them is going to crash in runtime, because I assume there is a lot of differences between those libraries. So this is what we call a dependency hell. So how we practically solve this problem? We are doing something called shading. What is shading? It's basically embedding the dependencies inside the jar and rename the classes inside. For example, if the classes is started from org Apache Common, I can now relocate them to come through shaded org Apache Common. It's basically a managed way to copy and paste the all content of the dependency inside the jar. And now what we are going to do is to take the required dependency from the POM, because I already copy it into my jar. I relocate it. And it's something we called a reduced POM. The POM for the library has no longer specified the dependency that I already copied inside. So let's take a look of a simple example. I took something that is old enough. Its vulnerabilities inside I assume, will not affect the world much today, because it's more than 10 years old library. But what I did here is create an application, a simple one, and specify one dependency. For example, here it's the com-auth0 Java JWT in version 1.0.0. And now I want to test what vulnerability there is inside. I will start with a simple thing. I will run a Maven dependency tree and see. I want to resolve all the dependency, all the dependency that I have in my project. So here you can see that I have my project, my root project here, and there is only one dependency. And basically, what I can learn from this dependency tree, that there is no other dependency relevant to the com-auth0. So let's inspect this from Maven Central. We will see the POM that we have from Maven Central for this dependency. And of course, there is only one dependency. It's the JUnit, and it's in a test scope, which means it's okay that I don't see it in my dependency tree. It will not get to the final artifact because it's a test dependency. So now we can start explore what vulnerability there is inside. So I'm going to Maven Central, and as you can see, there is only one vulnerability. This vulnerability is coming from dependencies. The dependency that it came from is the JUnit, which is not relevant for us. I can skip for this. It seemed like it's okay. Anyone work with deps.dev by Google? Okay, basically deps.dev is an inventory of open source for some ecosystems, for example, Java, Python, and the other bigs. Deps.dev is the security advisory is based on osv.dev, also by Google, which rely on NVD or and GHSA. And what I can learn from this that there is no vulnerabilities in COM-OS 0. I think it's fine. Let's try the SNCC. SNCC developed a proprietary vulnerability database. They research vulnerabilities with a researcher. So let's see if they see anything that the other miss. So according to SNCC, there is no vulnerability in COM-OS 0. Let's try and scan the my POM XML with SNCC. They identified the correct one, the correct COM-OS 0 Java JWT dependency. There is only one. And as you can see, there is no vulnerability even from SNCC. So the other methodology to try and see if there are vulnerability is to try and compile this artifact. I packed in into a container and run Trivi. It's an open source tool. And here we can see that there is something interesting. There are 49 vulnerabilities, 19 critical, 27 highs, which is interesting because it specified that we have Jackson core and Jackson data bind dependencies with install version. And now I can resolve all the dependency by upgrade those dependencies. So let's try and do it. We will run dependency tree and we will try and see where those libraries came from. And again, there is not those library is not present in my project. So what we can see here that I can't upgrade it. I can't upgrade those Jackson core or Jackson data bind. I can see them. I didn't bring them, not even transitively. So how Trivi did this? Basically, let's dive into the jar itself. I take the COM-OS 0 JWT jar and unzip it. And then I go to a metadata folder which contain some interesting files called POM properties. And those POM properties specify the jar that and the dependency that's packed inside. So for example, here we can see that there is the the Jackson core in version 2.0.0 and the Jackson data bind. So Trivi wasn't lying about it. So how it's made? So basically, what we see here is shading. Let's explore the source of this dependency. So I go to GitHub, check out the version 1.0.0, and then I can see that there are actual free dependency, the Jackson data bind, the common Kodak, and the famous JUnit from before. And now if I'm continuing the POM, I can see that there is a process that call shading. They're using Maven Shade plugin. The goal here is to shade. And we will generate a reduced POM. What I spoke before, we reduce it from the POM that we deliver to the Maven Central, and we relocated the packages. So it's no longer com faster XML JSON, it's something else. For now, I can't tell it from this, but let's continue with this. So we want to see if it's a theoretical problem or is it a real one. So we took our platform and scan the project in the GitHub. We found that there is 49 vulnerability. 5 of them we consider as reachable. And we can explore the call graph, and we can see that there actually seems like a real risk. We have, if we see the call graph, we see that we call the verify. Actually, it is, we want to verify a JWT token from the user, and then we call to the decode and parse, and then we deep down into the comfaster XML word till the vulnerable function. We can see here that there is the relocation pattern. It's no longer comfaster XML JSON. It's com0 JWT internal comfaster XML JSON data bind. And here we can see an interesting part where Trivi tell us to upgrade the JSON data bind from version 2.0 to 2.12.7.1. We didn't find it. So the actual upgrade that we need to do here is to upgrade from com0 Java JWT in 1.0.0 to 3.0.1. This is the actual artifact that contain the vulnerability. So our motivation was to see what is the impact of all of these shading parts, because we saw this across our customer base. We saw that there are a lot of shading, both from open source, both from internal developed libraries, and we want to see the impact. So what we did is to go to Maven Central. There are more than 16 million artifacts there, and we analyze each one of them and try to map what are the shaded dependencies inside those artifacts. And then we want to map for each one of them what vulnerability is contained inside. So the amazing part that we discovered is that there are a lot of vulnerabilities are hidden inside. More than 2.5 vulnerability, 2.5 million vulnerabilities. You can see here that there is nearly 5,000 vulnerable packages that they are still vulnerable in the latest version, which means there is no fix available for them. There are more than 8,000 CISA-CAV criticality vulnerability, near 500,000 critical one, more than 3K log4j instances, some of them in the latest version of some packages. And basically there are a lot of terrifying vulnerabilities. Most of them for the sysacav. They are exploited in the wild. There are a lot of POC for them. There are a lot of other vulnerabilities related to Guava or Jackson databind or Log4j, or really a lot of shitty vulnerabilities inside that are hidden. That's it. Anyone have a question? Okay, thank you very much.